Hi. Welcome to our talk. I'm Eyal from IBM Research, and I am here with Yanis, also from IBM Research. Today, we will present the open source no-code Label Sleuth system and explain how you can use it to quickly create your own text classifiers. To motivate our work, I'll start with a true story. IBM lawyers came to us with a problem. They had a collection of very long contracts and needed to identify clauses within those contracts that signify a risk. Manually searching and reading hundreds of long legal documents was obviously extremely inefficient and expensive. Thus, they came to us asking if we could help them leverage machine learning to train a text classifier, to create a model that would automatically classify the contracts for them as the clauses as risky or not risky. At this point, the obvious answer for us as machine learning experts was to work with them and help them train a model for their particular use case. However, having been there before, we knew that this would not scale. Whenever the need of the lawyers changes, for instance, the need to identify a new type of risk, they would come back to us, and would have to repeat the whole process all over again. Thus, we started asking ourselves, instead of creating a one-off model for them, could we build a general labeling and model building system that would allow lawyers to build a text classifier themselves without our help? So, welcome to Label Sleuth, an interactive no-code system that enables domain experts, such as our lawyers, to quickly create their own text classifiers. Taking a step back, the general problem we are trying to solve looks like this. Domain experts have a large collection of documents whose text they need to classify through a machine learning model. Since they may not know machine learning, they typically reach out to machine learning experts. And this is where a week or even month-long process of asynchronous model building begins. The process typically consists of two alternating stages. In the first stage, the domain expert painstakingly annotate a lot of documents. What should they label? When do they stop? In reality, the decision is often arbitrary, as they receive limited guidance by the machine learning experts. In the second stage, the domain expert is out of the picture, and machine learning expert then take the labeled data, which is static at that point, and try to train a model. In this process, they find label inconsistencies, insufficient examples for some categories, and redundant examples for others, which in hindsight was a waste of labeling time. Based on their insight, they go back and ask the domain expert for additional labeling. With limited interaction between those rounds of labeling and model training, weeks and months can pass before a domain expert can finally use their machine learning model. This makes model labeling expensive and out of the reach for many domain experts. It is a real barrier for many to do supervised machine learning. We hear it from customers that they don't start machine learning because of the labeling barrier. To avoid these issues, we present Label Sleuth, a labeling and model building system that makes domain experts the main drivers of the model building process and allow them to autonomously create their own text classifiers without requiring the help of machine learning experts. Label Sleuth serves in some way as the personal machine learning expert assistant to those domain experts, continuously assisting and guiding domain experts through the combined labeling and model training process. In short, Label Sleuth is an open source, no-code system that allows domain experts to quickly build text classifier for their use cases. No AI knowledge is required. To accomplish that, Label Sleuth combines the following features. First, an intuitive graphical user interface, allowing domain experts to quickly start labeling their data with no need for complex configuration or understanding of technical jargon. usually with very minimal training to start using the system. Sorry. While the domain expert is labeling the data, Label Sleuth automatically trains an appropriate machine learning in the background. And as the user provides additional labels, Label Sleuth automatically trains improved versions of the same model. All this happens transparently to the user. Complex decisions such as the type of the model to train, when new training should be invoked, and other things are automatically made by the system. To avoid wasted labeling effort, Label Sleuth does not let domain experts simply label at random. Instead, it employs a variety of machine learning and NLP techniques to guide them into what label next and how to make most of their limited and often expensive time. Finally, while Label Sleuth is easy to use out of the box for domain expert, it also allows for extensive customization for more advanced user that may want to use the system for their own use cases or to support domain expert. I imagine most of the audience here is part of this set of advanced users. The combination of these features leads to a system tailored specifically to non-technical domain experts. Okay, so to better demonstrate the ease of use of the system, let us quickly demo how a domain expert can use Label Sleuth to create their own text classifier. For this demo, please meet Vicky. Vicky is a Wikipedia editor with deep knowledge about animals. To improve animal pages, she wants to find sentences that describe the habitat of animals, such as the one that you can see on the screen. Her goal is to review and correct this information if needed, and also to find pages that currently miss the habitat information. Vicky is not keen to manually read every single animal page in Wikipedia. Instead, she will use Label Sleuth to create a classifier that identifies habitat sentences automatically for her. Okay, so she starts with uploading her data of a pre-processed document. It's a simple CSV file with 2 columns, text and possibly document ID. And then she creates a workspace, which is like a project that can bundle several categories, several classifiers together. Now you can see the main screen of Label Sleuth. In the middle, you can see one of the pages of Wikipedia. Then she starts defining the habitat as the category of interest and start labeling elements for that category. She can skim through documents and label sentences one by one, as you can see now, but this won't be very productive as habitat sentences are quite rare. To quickly find positive examples, she uses the search functionality to find sentences that contain the word habitat. Note that not all of them are positive examples. She goes through a few search results and quickly labels them as positive or negative. When needed, she clicks on a sentence to see it within its document and make a decision based on its context. She continues by searching additional terms, such as lives in, is endemic to find more examples and label them. While she is labeling, Label Sleuth collects her labels and decides when it's time to start training a first version of the classifier. This is done automatically in the background without interfering with the labeling process. When a first version, as you can see now, of the classifier is ready, Label Sleuth notifies Vicky through a confetti animation. As Vicky provides more examples, Label Sleuth automatically trains new, improved version of the classifiers. Once Label Sleuth has trained the first version of the classifier, Vicky starts to receive additional labeling assistance, and this is the new part. First of all, she can see a list of sentences that the system suggests she labels. And these are the sentences that Label Sleuth thinks would be most valuable to improve the classifier. Vicky goes ahead and label the suggested elements. Since Label Sleuth has already built a first model, Wiki can also check its predictions, meaning the sentences it identifies as positive examples. For instance, while checking this page about an African elephant, she can easily inspect the small number of sentences identified by the classifier. These are those sentences framed with the bullish dotted line. She sees that the first prediction is wrong, corrects it, and the next two are correct. By validating those predictions or correcting them as needed, Wiki helps the classifier correct its mistakes and improve in the next iteration. While labeling, it is natural to introduce mistakes. While these are often unavoidable, it is good to identify them early on to avoid introducing noise into the classifier. To this end, Label Sleuth surfaces the sentences whose labels are suspicious and allow Wiki to inspect and, if needed, correct them. Wiki can also initiate an evaluation test to get a better estimation of the classifier precision. This is very helpful to determine when it's time to stop labeling. Okay, when Wiki sees that the classifier's predictions are getting better and its precision evaluation is good, she can stop labeling and start using the classifier. She can use the classifier in 3 different ways. The first that you see here is the simplest way to upload new documents and then the classifier's prediction through Label Sleuth UI as usual. Alternatively, she can download the classifier itself and hand it over to a developer to integrate it into a downstream application. Or she can even download the raw labels and use them herself or with someone else help to train another model outside Label Sleuth, thus treating Label Sleuth as an extremely efficient labeling tool. To summarize, people who use Label Sleuth have reported that it has saved them a lot of time, that it is easy to use, fun, and even a bit addictive. And now, with that, I'll now pass you to my friend Yanis for an in-depth analysis of Label Sleuth features. I'll stop sharing my screen, Yanis, and you can do it.
Hello, everyone. Can you see my screen?
No, we just can hear you.
Let me try again. Does it work now?
Not yet.
Okay, if not, Eyal, do you mind sharing? And
yeah, I can continue sharing my screen. And this one. Do you see it? Yanis, do you see the screen?
Not yet.
It is here. Let's try something. How about now?
No.
Then it's a Steve, I think it's because I'm backstage. Is it possible? Steve, the moderator. I'm sorry. I see that I share my screen. I can stop sharing it, but you don't see it.
Yes, I don't.
So we need your help here, Steve.
Yes. Yeah, sorry about that.
So I'm doing the same as before, but now my screen is just, I can see it, but not the rest.
Yeah, Giannis, have you tried sharing your screen?
Yes.
Please. I'll just be brute and remove both of you from the stream and then re-add you.
Okay, sounds good. Thank you.
All right, I can see your screen, your slides now. Label Sleuth. I don't see your face though.
I think as long as
I think there you go.
Thanks a lot. Okay, then I can go ahead, and if you could add AL back in, that would be great. But I can go ahead with the presentation.
Hi.
Thanks. Now that we have seen the efficient model building experience that Label Sleuth allows, let's see what are the features that enable this experience. Having seen Label Sleuth's intuitive UI, we will next focus on the three other features: integrated model training functionality, labeling assistance, and customizability. And we will explain them one by one. To make the model building experience accessible to non-technical domain experts, Label Sleuth offers integrated model training functionality. While the domain experts are labeling, Label Sleuth automatically trains a classifier in the background without requiring any intervention by the user. In order to accomplish this, Label Sleuth automatically makes a lot of decisions that are related to model training in the background. These are decisions such as what is the type of model, machine learning model, that should be trained? Should it be a support vector machine? Should it be a BERT model, etc.? The second decision is how to address a potential dataset skew. When domain experts label, they may, for instance, provide a lot of positive examples, but they may barely provide any negative examples. This may lead to a very severe skew in the label data that the system has to deal with and resolve before it can use this data for training. And third, the system has also to decide when it should start training the model and how often it should retrain the model as the labeler provides more and more label data. Traditionally, these are decisions that would have been made by a technical person that builds the model. But in the case of Label Sleuth, these are automated through the use of integrated policies that take care of each of these aspects. The domain expert does not need to chime in and does not even need to be aware of them. That being said, as we will see later, Label Sleuth also offers advanced users the ability to customize and tweak these integrated policies to their liking if they prefer. In addition to abstracting the machine learning process, another way in which Label Sleuth makes the process accessible to non-technical users is by offering continuous labeling assistance. Labeling is pretty expensive, and leaving domain experts label in an unguided fashion could lead very easily to wasted effort. In order to avoid that, Label Sleuth guides domain experts through the entire labeling process. In particular, it helps domain experts understand what they should be labeling, how they should be labeling it, and when they can stop labeling and can start using their classifier. First of all, it guides them in what to label. Intuitively, not all labels have the same value. For instance, labeling a lot of very similar elements is arguably not as useful as labeling a more diverse set of elements. This is why Label Sleuth tries to focus the labeling effort on the examples that are more valuable for the model to improve. This is done through the use of an active learning technique that produces a ranked list of examples that are more beneficial to be labeled in order to lead to improvements of the model. Label Sleuth incorporates multiple active learning techniques, but the default policy is based on uncertainty-based sampling. In a nutshell, uncertainty-based sampling picks the elements that the model is most uncertain about. So the elements that the model cannot confidently tell whether they're positive or negative. In technical terms, this would be the elements that are close to the decision boundary between the positive and the negative classes. In addition to suggesting to the user what to label, it also offers some guidance on how the domain experts should be labeling things. It is not uncommon that during the labeling process, labeling consistencies are introduced. For instance, a domain expert may label something as positive, then take a coffee break, and then come back and label a very similar element as negative. What is important is to identify these inconsistencies early on and to resolve them to avoid introducing noise into the underlying classifier. To do this, Label Sleuth offers two ways of identifying and surfacing labeling errors. The first one is the identification of suspicious labels. To do that, it takes the predictions of the currently trained classifier and compares them to the labels that the user has provided. And it finds elements where the classifier disagrees with the human-provided label. And these are intuitively elements that are suspicious. It means that this could potentially be labeled wrong by the user. Please note that there is much more to it, but for the purposes of this talk, this should convey the intuition. In addition to identifying suspicious labels, the system also identifies what we call contradicting pairs of elements. These are elements that are very similar to each other semantically, but they have been labeled by the user in different ways. So one of them has been labeled positive and the other has been labeled negative. And intuitively, these are, again, pairs of examples where a labeling error may have occurred, so the domain expert could inspect them and correct one of the labels if needed. Last but not least, the system also provides information on when the domain expert should stop labeling. While using the system to label data can be enjoyable, remember that this is not the end goal. So the end goal is to create a good classifier. Thus, the system is trying to help the domain expert understand when the classifier is good enough so that they can stop labeling and start using it. To this end, it provides the domain expert with a way to evaluate the model. At any point in time, the domain expert can invoke a precision evaluation. At that point, the system will auto-generate a sample of elements for the domain expert to label, and after they have been labeled, it will estimate and present to the user the precision of the current classifier. And when the user thinks that the performance of the model is high enough, they can stop the labeling process and start using the model. Let us now talk about the customizability of the system. So far, we have talked about features that are related to domain experts, non-technical users, which are also the primary target users of the system. However, as Eyal mentioned, there is also a second set of users that we found can benefit from the system. These are more technical users that may want to use the system either for themselves or while supporting domain experts. To facilitate the use of the system by these more advanced users, a Label Sleuth is built on a highly customizable architecture. Most of the features that we have presented above can be customized. So among others, the type of model to be trained, the way to deal with the data set skew, the criterion to decide whether to invoke training or not, the active learning algorithm, etc. And in order to allow customization, Label Sleuth offers a two-tier customization architecture. Common customizations can be easily done by customizing the configuration file. For instance, let's say that we want to forego the default model that is trained by the system and want to pick a different one. Label Sleuth comes pre-implemented with different types of machine learning models, including naive Bayes, support vector machine, BERT, and what we can do is select one of them by editing the configuration file. And if our favorite model is not there, then we can easily extend the system by implementing the corresponding API. In the case of the models, this would be equivalent to implementing 3 functions that are explained in the system's documentation. This concludes our brief summary of the main features of Label Sleuth: intuitive UI, integrated model training functionality, labeling assistance, and customizability. With all of this together, Label Sleuth creates an easy-to-use system that enables domain experts to quickly build text classifiers on their own, no AI knowledge required. For instance, to go back to the example of the IBM lawyers that we started this presentation with Label Sleuth, they were able to work for about 6 hours to build a classifier that saved them about 80% of the time that they would have otherwise needed in order to go through the contracts and identify the clauses that are risky. If you want to learn more about the system, please visit the website at label-sleuth.org, where you can find information on how to install and try out the system, documentation, a link to our GitHub repository where you can check out the code and contribute to the project, as well as a Slack space where you can join the discussion about the system. Hope to see you all there. Thank you.
Thank you very much.
Thank you very much. Thank you very much, guys. You got a couple more minutes. Would you like to answer any questions?
Sure. How do we do this?
Oh, let me check in the. You mentioned how sleuths can send suspicious labels back to the expert. Does Sleuth keep track of how often a label has been reevaluated and consider that when when determining suspiciousness of a label?
Yeah.
That was from Bruno.
Thank you. Thank you for the question. So currently, no, but I can imagine how easy it to contribute this piece of code to Label Sleuth, and by that, generate a new way to identify suspicious labels and help fix more types of labeling errors. And as we mentioned, this is an open source, and we call out for the community to join and add features as needed. Still, do we have any other questions? I may add about support of various languages. So we built Label Sleuth with English models, but it is very easy to add additional languages. For instance, an external contributor from Italy asked about Italian. We didn't have it. After a few, I think, hours of work, he was able to upload the stop word list and glove representation for Italian, and now Label Sleuth support Italian. So in terms of presenting the documents, running the models, everything is ready for multilingual. You just need to specify a couple of files describing the language of your interest.